The quickest way to kind of look at this is to look after the one log and see how many values and terms you have, or how many terms you have. So I have a 5, I have an x, and a y. So I should end up with 3 logs. So notice first that there is the division sign. So that means to take the top, which is 5x cubed, and we're going to subtract, make sure you add a log to this, log base 6 of y. Now I notice that I have a 5 and I have an x cubed. So I'm going to break that apart. Anything that's multiplied can be broken up with an addition sign. So I've got log base 6 of 5 plus log base 6 of x cubed, and I still had my log base minus log base 6 of y. The last thing I want to do is I want to try to not have any exponents. So I'm going to take this exponent, I'm going to move it in front of this log to end up with log base 6 of 5 plus 3 log base 6 of x minus log base 6 of y. Now the only thing you might be able to do, we're done with this one, but the only thing you might be able to do is simplify when there's all numbers. So always kind of double check. Let's try another one. Notice in this next example in the beginning that we have a 5, an x, a y, and a z. So we have 4 terms. So I should end up with 4 logs. Where in the first one I had 3 terms, I ended up with 1, 2, 3 logs. Alright, so let's try to break this one up. Everything is multiplied. There's no fractions, which means I'm not going to have any subtraction signs. So I'm going to start log base 3 of 5 plus log base 3 of x squared. Notice I'm making sure my logs have the same base. Plus log base 3 y cubed. And finally, plus log base 3 of z. Last thing you're going to want to do is move any of the exponents in front of the log. I'm going to jump way down here because I'm running out of room. So I've got log base 3 of 5 plus 2 log base 3 of x plus 3 log base 3 of y, and finally plus log base 3 of z. So we just took that one log and expanded it into 4 because we started with 4 terms. Let's try a couple more exciting ones. Alright, we are going to have to remember what we did back in the last chapter. So in the last chapter, we learned that the square root of x can be rewritten as x to the 1/2 power. Because I really didn't teach you anything to do with a radical, but I did show you something we could do with an exponent. So I'm going to rewrite this as log base 4 of 2 times x to the 1/2. Since we have a multiplication sign, I can break that up into 2 logs that are split up by an addition. So if there's a times, we can split them up with an addition. Log base 4 x to the 1/2. Only thing I can really do now at this point is take this exponent and move it out front, leaving me with log base 4 of 2 plus 1/2 times log base 4 of x. Now maybe you think you're done, but if you look at this right here, notice that the base is a 4 and then there's a 2. There's ways to simplify a 4 and a 2 so that we can break this up. So I'm going to come over here and I'm going to set just this part, log base 4 of 2 equal to x, and I'm going to change it to exponential form. The reason I'm doing that is because right now in my head it's kind of difficult to take that log base 4, change the 2 into 4 to some power. Now maybe you know what to do, but we're going to try this differently. So I'm going to take the base of 4, raise it to the x power is equal to 2. 2 is to the first power, so I'll just fill that in. I can take the 4 and rewrite that as 2 squared. There's still an x in the exponent, and now I have the same base. 2x is equal to 1, divide by 2, So that log base 4 of 2 simplifies to 1/2. So now I can come back and rewrite this as 1/2 plus 1/2 log base 4 of x. Now, you might be thinking that maybe you can add the 1/2 and the 1/2, but the second 1/2 is really being multiplied by the log base 4 of x, so you can't do anything else, you're completely done. Let's try another one. Alright, notice there's a 3, an x, and a 10. Now the 3 and the 10 can't be simplified, so I might end up with 3 different logs. First thing I'm going to do though is I'm going to rewrite this as, let's rewrite this as, it's the square root of x cubed. I'm going to rewrite that as x to the 3/2 power. So right now I have log, that's an ugly log. Log base, no, there's no base. Remember, that means base 10. So I've got log base 3 times x to the 3/2 power over 10. The fraction is telling me I'm going to split up and have a minus sign between two logs. So I've got log base 10 of 3 times x to the 3/2 minus log of 10. I still have this times sign right there, so I'm going to break up this into log base 10 of 3 plus log base 10 of x to the 3/2. And then finally minus log base 10 of 10. Maybe you've already realized that this log base 10 of 10 is going to cancel into just a 1 because that exponent is 1. So if you want to just go ahead and write that, we're done there. This exponent is going to have to come out in front. So right now I've got log base 10 of 3, can't do anything with that, plus 3/2 times log base 10 of x minus 1. Remember, this simplifies to 1. And that's all we can do. Alright, what I want you guys to do is hit pause, get a calculator, because this is going to be pretty cool. I think you're going to like this. The change of base formula is a way to rewrite ugly logs as common logs. Remember, common logs are base 10. So this is going to allow us to rewrite it with common logs, a base 10. So you might think, okay, that's stupid. Why do I care about a base 10? The nice thing about a base 10 is that you can use your calculator. So if you have log base c of a, you can actually rewrite this as log base 10 of a divided by log base 10 of c. Or, if you like natural logs better, natural log of a over natural log of c. Notice, whatever the base is always a number that kind of hangs down, is going to be in the denominator. And then the number right there is always going to be the one in the numerator, up on top. Alright, let's try some. And again, you really want a calculator to do this because that's really what makes this so cool. Alright, so I'm going to rewrite log base 9 of 27 as log base 10 of 27 divided by log base 10 of 9. Now, maybe you are realizing that you could have just done work on this one. So you could have set this equal to x, and you could have done 9 to the x power is 27. So then you could have done 3 squared, there's an x up there, equals 3 cubed. So 2x is equal to 3, so x equals 3/2 or 1.5. If you get your calculator out though and actually type this into your calculator, if you have the nice one with the fraction, you can actually open up a fraction button, type log 27 on top, type log 9 at the bottom, hit enter, and your calculator should tell you 1.5. Now this one it didn't matter since we could have just broken it up by making the bases the same, but that doesn't always work. If you look at this next example, it's a 2 and a 35. There's no way you're ever going to make a 35 be a base of 2. But if you rewrite it as the log base 10 of 35 over log base 10 of 2, type that into your calculator, you should get 5.1293. And it says to round 4 decimal places. So please try that. Maybe try the next two. Example C, I'm going to do log base 10 of 1/2 divided by log base 10 of 12. Type that in the calculator and you get negative 0.2789. Think maybe for a minute, why would B be positive and C be negative? If you can figure out why, let me know in class tomorrow. I'm curious to see if you can figure out why C would be negative and B would be positive. Alright, on D, D's another one. If you look at the 32 and the 8, it actually is possible for you to just do the work yourself, set it equal to x. So then you could do 32 to the x power is equal to 8. 32 is 2 to the 5th. There's an x up there. 8 is 2 cubed. So you could just do 5x is equal to 3. 3 divided by 5 is 6/10. Or, if you wanted to now, you could just take this and rewrite it as log base 10 of 8 over log base 10 of 32. Type that into your calculator and you will get 0.6. You could also go back with any of these and you could do the natural log instead of log and you should get the exact same answer. So if you want to kind of mess around with that. Alright, we're done with this, but go ahead and try the buzz assignment, or if you want to wait and try it in class tomorrow, go back, make notes of anything that you have questions on, and we will go over those in class. See you guys tomorrow, or whenever.